Hi guys, in today's video we are going to focus on simplifying surds. So this is the question that we will be doing for the day. Now let's begin. So the first thing that you have to do when it comes to simplifying surds, you must convert your whole number inside your square root to its simplest prime factor. Right, so now let's look at our whole numbers inside our square root. So we have 20 and we have 8, right? So now let's start with 20, right? So in 20 we know that we have 5 times 2 squared, it's minus 3, a square root of 2 cubed, divided by square root of 5 minus 1. Now on the square root of 5, there's nothing that we can possibly do to convert the 5. So 5 is at its simplest prime factor, right? So there's no need for us to convert it. So now let's look at the next step. The next step is for us to simplify. So we have 5 times 2 squared. This would be equal to a square root of 5 times a square root of 2 squared. Now, the reason why we can separate them and use the same square root at the same time is because they are multiplying each other. So if we had a square root of 5 plus 2 squared, this would not be equal to a square root of 5 plus a square root of 2 squared. This only applies if we are multiplying the terms. If we're not multiplying the terms, then this a law that does not apply. So from here we have a square root of 5 times 2 squared 1 over 5. So now a square root is equivalent to a half, right? So there's another exponential law that says that if you have n to the square root of a, this would mean that you have a 1 over n. So for an example, if we had 3 square root of a, this would be a 1 over 3. If we have 3 square root of a squared, this would be a squared 1 over 3, which then gives you a 2 over 3. So remember this law. It's very important that you remember them because you are, like, most of the time you are going to have to apply them when it comes to simplifying your surds. So now from this point, 2 times 1 over 2, that's going to cancel out. So now you have a square root of 5 times 2, which is 2 square root of 5. Now let's look at the next one. We have 3 square root of 2 cubed, right? So now this, can you see that this is almost the same as this? So now this would mean that we have 2 cubed 1 over 3, then these will cancel out, so we have 2. Now let's come back to our expression. So now we have 2 square root of 5 minus 1, minus 2, is divided by square root of 5 minus 1. So now we can see that 2 is our highest common factor, therefore we can take it out and factorize our expression. So now this would mean that we have 2 open bracket square root of 5 minus 1 square root of 5 minus 1. Therefore we can cancel them out, right? This would mean that we have 2. So what if we were not able to factorize or take out the highest common factor? How were we going to solve this expression? Right, so let's just ignore this, right? Let's just ignore this last part and look at this, right? Let's say that we were not able to factorize it. What were we going to do? So 2 square root of 5 minus 2 divided by square root of 5 minus 1. So on this point, we introduce what we call rationalizing. So basically when you rationalize, we are removing the square root as a denominator. So the most important part of surds for you to remember is that we do not want to see or to have a denominator that has a square root, right? So if we can look at this, our 5 has a square root. So how do we remove that square root? You multiply the numerator and the denominator by that exact original denominator. But if it has an addition or a subtraction sign in between, then that sign will change, right? So that's square root of 5, right? Instead of saying minus 1, we are going to say plus 1. Square root of 5 plus 1. So what if we did not have an addition sign, right? So this would mean that it would be a square root of 5 divided by a square root of 2. So if you do not have any addition or subtraction sign on your denominator, then you can just multiply the numerator and the denominator by that original term. You do not have to change the sign because there's no sign to change in the first place. So it's a square root of 2 and a square root of 2. The only time that you have to change the sign if you have an addition or a subtraction sign in between your terms. Right, so now we're multiplying them. So this would mean that we have 2, right? We have 2, a square root of 5 minus 2, a square root of 5 plus 1, divided by a square root of 5 minus 1, a square root of 5 plus 1. Right, so from here, this would multiply this would multiply this, and this will multiply this will multiply this. So 2 square root of 5 times the square root of 5. So that means that we have 2 square root of 5 times 5, and then 2 square root of 5 times 1, that will be plus 2 square root of 5 minus 2 square root of 5 minus 2. It's divided by a 5 times 5 minus square root of 5 plus the square root of 5 minus 1. So since these are like terms, they cancel each other. Now we're left with 2 square root of 25 minus 2 divided by square root of 25 minus 1. So now from here, we have to convert our whole number into its simplest prime factor, right? So we have 2 a square root of 5 squared minus 2, because 5 squared, it's going to give us 25, divided by a square root of 5 squared minus 1. So now this would mean that we have 2 5 squared half. Remember, a square root is equivalent to a half. So now we have 5 squared half minus 1. Therefore, this will cancel out. So now you have 2 times 5 minus 2 over 5 minus 1. So now from here, we have 10 minus 2 divided by 5 minus 1, which is 10 minus 2 is 8, and 5 minus 1 is 4. This would be equal to 2. So you see, our answer is the same as the one we got when we factorize. So remember, when you cannot solve the expression, when you have a square root on your denominator and you cannot factorize to get rid of that square root, then you must rationalize the expression. If you have an addition sign in between or a subtraction sign, then when you multiply the numerator and denominator, the sign will always change. But if you do not have any addition sign or subtraction sign, then you multiply by that square root. Those are the most important steps that you need to always remember when it comes to simplifying surds. Thank you for watching. Please like and subscribe to our channel to receive more videos, and you can also leave a comment to how we can improve our sessions in order to give you a quality videos and also good content. Thank you for watching.